All right, this is a video lesson for Unit 5, Lesson 1, which is parameter versus statistic. Now, the first thing that you'll notice is that I have talked about the fact, or written out, that Unit 5 is about something called hypothesis testing. Now, you haven't learned about hypothesis testing, but it's probably the most advanced application of statistics that you will learn in this class. So it's a really important unit for us. And this first lesson is going to feel a little bit out of character compared to the rest of the unit. But it's really important before we get going that we understand the difference between parameters and statistics, as hypothesis testing itself talks about both, and it can be a little bit confusing to differentiate between the two. So moving into our definitions, first thing we're going to talk about is a parameter. A parameter is a measurement describing an entire population. I want you to highlight those. The reason I'm highlighting these is because parameter and population both start with a P, and that's kind of an easy way to remember which one's which. That parameter starts with a P and it goes with population. So if you have a measurement like a mean or a standard deviation or something we're going to learn today called a proportion, if you have one of those measurements and it describes an entire population, that's called a parameter. The issue with this is that you have to have a data value for every member of the population. So if you want to make a statement about the entire country, you need to have 350 million pieces of data, which is pretty unrealistic. That's where statistics come in. A statistic is a measurement that describes a sample of a population. So this time we're going to highlight the S in statistic and the S in sample. This is the easy way for me to remember this one, that a statistic describes a sample as they both start with an S. This is much more realistic to obtain. It's much more realistic to get a sample from a population than to actually get all the data values from the entire population. The study of statistics, really in general, is about using samples to make conclusions about populations, meaning that we're going to find statistics, the name of the class, in order to make predictions about parameters. And that's exactly what hypothesis testing is. So, now that you kind of have a little bit of a background, you might want to try these two problems without watching the video first. So pause the video and then come back and see how you did. So, for number 1, it says, it is known that 10% of all players on the Chicago Cubs have a college degree. So, here's the key word here. All players. Keywords. All players on the Chicago Cubs. So, we're describing all of the Cubs. That's a population. The population is Chicago Cubs players. Okay? So, this 10% that we know of Cubs players is describing the entire population of Cubs players. So that makes it a parameter because it describes the entire population that we're dealing with. So that makes this a parameter. Number 2, 4% of 100 MLB players. So if you aren't aware of this, MLB is the Major League Baseball league, and it has a lot more than 100 players. There's 30 players per team, 26 players per team. So just 4 teams out of the 30 have 100 players. So this is not describing the entire population of MLB players. It's only describing a sample. This right here is a sample. That means that this 4% here is a statistic because it's only describing a sample. It's not describing the entire population. Now, let's specifically talk about means. A mean can be given with 2 symbols. This symbol, pronounced mu, which you've learned throughout this entire class, is a parameter. It describes the mean of the entire population. Now, X bar down here, this is a little bit less used so far in this class, but will be used quite a bit in hypothesis testing. X bar is a statistic. It also represents the mean, but it represents the mean of a sample, not the entire population. So, what we're going to do is we are going to go and find the mean of this set of data down here, and we're going to use proper notation to state our answer. So first of all, we need to know how to find this, and we're going to use our calculator to do that. And second of all, we're going to need to know what to name it. So this says the heights in inches of 10 randomly selected Glenbard East students. Well, we know that there's a lot more than 10 students at Glenbard East. So this is a sample of the population. That means that our answer is going to be a statistic, and X bar is the mean statistic. So our answer, whatever it ends up being, is going to be X bar equals. And then we got to go find this number. So we're going to do that using our calculator. Now, I've already typed in this data into my calculator. I'm going to switch modes here and go to my camera. So here's my calculator. I have already gone to Stat, hit Enter on Edit, and I typed all those data values into this table. So there's 10 values. I've typed it into this table. You may want to pause the video and do that yourself. Once you've done that, I'm going to quit out of this, and I'm going to go to Stat, Calc, 1var Stats. So I hit Stat, I slid over to Calc, and I'm hitting Enter on 1var Stats. Now, from what we were doing earlier in the semester, you might still have something like L4 in here instead of L1. So I'm going to hit second, and then the 1 to make it L1 instead of L4. Then I'll go down to Calculate, and it's going to give me this list. This top number here, X bar equals 66.2, that's the mean that we want. So I'm going to go back into Notability and put that answer down. That answer was 66.62. And it's describing the heights, so in inches, so we're going to put inches. And that's using proper notation to state our mean, because it's a statistic, not a parameter. Otherwise, we would have used mu. Now, this is a new thing for us, proportions. A proportion, and we're going to use this a lot in this class, a proportion is a percentage. It's a percentage of the population that meets a certain requirement. So this actually allows us to do our hypothesis testing, our high-level stats, on categorical data now, which is incredible. So now we don't only have the power to use normal distributions to calculate anything quantitative, we now have the power to go test anything categorical as well, which is really cool. Okay, so this symbol here is pronounced rho, okay, but we just use the letter P, and we can honestly call it P. So the letter P is a parameter. It represents the population proportion. So what percentage of the entire population meets whatever requirement we're dealing with. The statistic is P hat. Okay, so we've got P hat. It's called P hat because it looks like it's wearing a little hat. It's a statistic. So it's the same measurement. What percentage of the population meets whatever requirement, but it's for a statistic. So it's what percentage of the sample meets the requirement, not the entire population. So here's a problem. It says 63 of 221 randomly selected Glenbard East students. By the way, we have a lot more than 221 Glenbard East students. So this is a sample, meaning our answer is going to be a statistic. State that they believe the school enforces the dress code, or they believe that the school should enforce the dress code more strictly. Find the sample proportion and use correct notation. So because we are doing a sample here, and our answer is going to be a statistic, we're going to use P hat as our answer. Not just P hat. How we're going to calculate this is we're going to put the number of people that meet the requirement out of the total number of people. So P hat is going to equal 63 divided by 221. It's actually a really simple calculation. 63 out of the 221 think that Glenbard East should more strictly enforce the dress code. So 63 divided by 221, I'm typing this into my calculator right now, equals 0.285. So P hat equals 0.285 would be our final answer. And that's a sample proportion. using the symbol p hat. So finally, let's do some standard deviation here. Okay. In standard deviation, sigma, this symbol, the circle with the line on it, as some of you call it, is a parameter that represents the population standard deviation. So the amount of variation or deviation in the entire population. Where S is the symbol we use to represent the same measurement, but for a sample rather than the entire population. So this is a statistic where sigma is a parameter. They want us to find the standard deviation of this sample of 10 students' heights and to use proper notation to state it. So I go into my calculator, I'm going to go into edit, and this is actually the same list of data that we had earlier, so I don't have to retype it in. I already have it all, so I'm not going to have to do anything in the edit. So I'm going to go back into my camera and show you what I'm doing. So I'm going to go to Stat, Calc. I'm going to one-var stats a second time, doing the same thing I did last time. This time, I'm going to look for the S. It was a sample, so I'm not going to use this sigma calculation. This is where kids get confused. I'm not going to use the sigma. I'm going to use the S because it was this sample, meaning I need the S statistic, not the sigma parameter. So I'm going to use S, which is 4.61. So I go back into Notability. I'm going to use S, not sigma, because it's a sample. I'm going to use S, not sigma, and the answer is 4.61 according to my calculator. So to recap, because that's the end of this lesson, to recap, we found out that when we're talking about a mean, and these things are all going to come back in our hypothesis test, in a mean, mu represented the population mean, where x bar represented the sample mean. Then we learned in proportions, which are percentages for the population, we learned that p represents the population percentage or proportion, where p hat represents the sample percentage or proportion. And then finally, we learned with standard deviation that sigma represents the population standard deviation, where S represents the sample standard deviation.